Hello student, welcome to Learn Chemistry with Emerald. In this video, we are going to talk about particulate nature of matter. We are going to be looking at what particulate nature of matter is all about, distinguish between atoms, molecules, and ions with correct examples. We are going to define atomic number, mass number, and how they are used to describe elements. We are going to define isotopes and isobars and give two examples each at least. We are going to be able to calculate the relative atomic mass and the relative molecular mass. And finally, solve WAEC, NECO, JAM, and IGCSE questions on this topic confidently. Let's get the topic started. This is the overview of the topic. So we look at defining what particulate nature of matter is. Again, as you are being taught in your junior school, matter is anything that has mass or weight and occupy space. Matter usually exists in form of two things. Matter can exist as a particle or as a wave. So we call it the duality nature of matter, as a particle or as a wave. In chemistry and in this topic, we are going to be focusing majorly on the particle nature of matter. Matter as a particle has tiny discrete substances or particles in them, which are atoms, molecules, and ions. These particles are in constant motion. They have spaces between them and they attract one another. Let's look at the three discrete particles matter is made of. Number one is atom. An atom is the smallest part of an element which take part in a chemical reaction. The definition here is the classical definition before modifications were made. But matter was seen as an indivisible particle of an element that retains the chemical property of the element. But in modern times, matter is defined as the smallest particle of an element which take part in a chemical reaction. Of course, they retain the chemical properties of the element. An example is H atom, sodium, iron, oxygen, copper, calcium atoms. They are usually singular. A molecule is a substance, is the smallest particle of a substance that retains its individual properties and can take part in a chemical reaction. We can also define a molecule as the combination of two or more atoms. They can be of the same element and they can also be of different elements. An example is H2, O2, N2, which are of the same element, and H2O, CO2, NH3, HCl, which are of different elements. So when two or more atoms chemically combine or bond together, they form a molecule. The third one is ions. Ions are atoms or group of atoms that carry charges. Those charges are as a result of electron loss or gain. If an atom loses electron, it becomes a positive ion called cations. So an example is Na plus. Anytime you see plus on a particular element, that means it has lost electron. Sodium here loses one electron, and that's why you are seeing Na plus. Calcium loses two electrons, that's why you are seeing Ca2 plus. Aluminium can also have 3 plus. That means it has lost 3 electrons. And when you have substances that have negative on them, like Cl minus, that means it has gained 1 electron, or OH minus, SO42 minus, signifying that they have gained 1, 2 electrons respectively. So ions can be positive or can be negative. Ions that are positive are called cations. The ones that are negative are called anions. So atoms, molecules, and ions describes matter as a particle. They are the discrete particles of matter. What are the evidences for the particulate nature of matter? What evidences proves that matter is usually a particle or exists as a particle? Number one is Brownian motion, where you see small particles observed under a microscope move in a random zigzag path due to bombardment by an invisible air molecule. This experiment was demonstrated by Robert Brown in 1827 using polygrains in water. He puts polygrains in water and he observed that there are small particles using a microscope. So they place a microscope on that polygrain in water, and they observe small particles moving in a random haphazard motion. The second evidence is diffusion, which is the spreading of particles from a region of higher concentration to a region of low concentration until they are evenly distributed. An example is when booming gas spread in air, when NH3 and HCl meet to form dense white film of NH4Cl. These are examples of Brownian motion. Another evidence is dissolution or dissolving. When you dissolve a substance in water, an example is salt. If you add salt to water, you notice that the salt disappears. That's another evidence. And of course, it is because particles meet with water molecules, showing that both of them are made up of tiny particles with spaces between them. Another one is compression of gas. Gas can be compressed into smaller volumes because gas particles have large space between them. This also supports the particulate model. So, evidences that matter exists as a particle: Brownian motion, diffusion, you can also add osmosis, dissolutions, compression, then you can have condensation and evaporation to it. Let's look at the kinetic theory of matter. This is the key postulate of this theory. All matter is made up of tiny particles, which are atoms, molecules, and ions. They are always in constant random motion and usually faster at higher temperature and slower at lower temperature. There are spaces between these particles. There are attractive forces between the particles. And of course, when the particles collide, no kinetic energy is lost. That means the collision is elastic. Let's go to the second aspect of this topic, which is atomic number and mass number. Atoms, like we have discussed the other time, they are the smallest part, they are the smallest substance of an element, and they retain their chemical properties of that element. However, in the classical times, it was said that atoms were indivisible, but various experiments proves that atoms are actually divisible, and they are into 3 parts, which are called the subatomic particles or fundamental particles of an atom, which are proton, neutron, and electron. Therefore, by description, an atom consists of a central nucleus, and in that nucleus you have proton and neutron surrounded by electrons, which moves in an orbit or shell. This is the description of an atom. So the three particles in an atom are proton, which is positive, found in the nucleus, and of course with a relative mass of 1 and relative charge of +1. Neutron, which is neutral, relative mass of 1, relative 0, the charge is 0 and the location is in nucleus. And of course electron with a relative mass of 1 over 1840, which is equivalent to 0, and a charge of -1, and is usually in shell, is in shell which surround the nucleus. And this is the diagram that shows all the subatomic particles. You have the nucleus, which is the core of the atom, surrounded by electrons which are in orbits. So let's look at atomic number and mass number. Atomic number Z is the number of protons in the nucleus of an atom. The number of protons in the nucleus of an atom is also the number of electrons in a neutral atom. For neutral atom, of course, we have learned that we can have a neutral atom and then we can have ionic atoms, which are ions. When an atom is electrically charged, they are called ions. But when an atom is neutral, for instance, Na, the number of proton is usually equal to the number of electron. And that's why we can also still define atomic number as number of proton or electron in the nucleus of an atom. But we usually define it as number of protons in the nucleus of an atom so that it becomes a general statement. But if the element is neutral, we can say it is the number of electrons in the nucleus of an atom. Then the mass number is the total number of protons and neutrons in the nucleus of an atom. It is also called the neutron number. So the mass number which is designated as A is Z plus N, where N is the neutron number. Then the neutron number is the number of neutrons in the nucleus. It is usually calculated from mass number minus atomic number. Let's look at a typical sodium atom that has 2311. 23 is the mass number, 11 is the atomic number. And then of course, here the proton number is 11 because atomic number is the number of proton. So that's 11. And then the electron number is also 11. Why? Because it's a neutral atom. So the number of proton is equal to the number of electron. So proton is 11, electron is 11. Now to get the neutron number, we just say the mass number 23 minus the atomic number 11 gives 12, which is the neutron number. And this is how you write the proton, electron, neutron number of each atom and the atomic and the mass number of each atom. Do well to try with other elements or atoms. Let's look at work example. You have carbon. The notation of carbon is 12,6. So the proton number Z, which is also the atomic number, is 6. The mass number is 12. Then the neutron number will be 12 minus 6, that is 6. And of course, since it's a neutral atom, the electron number will also be 6. The same thing with other elements as the case may be. But of course, kindly note that if it is ionic, for instance, let's take the same sodium, Na. Let's take the same sodium, Na plus. That means in that case it's an ion, not an atom again. In an ion, the electron number is not equal to the proton number. In an ion, let's say you have Na plus, which is still 2311. The proton is 11. The electron is not 11 because that Na plus shows that the atom one electrons have been lost, so the electron is now 10, not 11 again. While the neutron is still the mass number minus atomic number, which is 23 minus 11, which is 12. So for Na plus, proton is 11, electron is 10, neutron is 12. Please take note of this. So let's look at isotopes generally. Isotopes are atoms of the same element having the same atomic number, but different mass number. An isotopes are atoms of the same element that have the same atomic number, but different mass number, which is due to difference in the number of neutrons. Isotopy is the occurrence. So if they ask you to define isotopy, isotopy is the occurrence of an atom having the same atomic number but different mass number. Isotopy is the occurrence of phenomenon. Isotopes are the atoms. Now let's take, for example, hydrogen can exist as H11, H21, then H31. Proton, which is one, that means the proton is 1, the electron is 1, but the atomic number is 1 for proton. The mass number is also 1, but it doesn't have a neutron. Why? Because neutron is gotten by mass number minus atomic number, which is 1 minus 1, and that's 0. So here you have proton is 1, electron is 1, neutron is 0. For deuterium, proton is 1, or the atomic number is 1, the mass number is 2. So proton is going to be 1, electron is going to be 1, but the neutron is going to be 1. That's mass number minus atomic number. That's 2 minus 1, which is 1. Then the same thing, use the same method for the tritium, which is radioactive in nature. The atomic number is 1, the mass number is 3. So the number of neutrons is 3 minus 1, that's 2. Electron is also 1. So these are examples of isotopes. And you can see their proton, their neutron, their mass number, and their common use. Let's look at isobars. Isobars are atoms of different elements that have the same mass number, but different atomic number, and different numbers of protons and neutrons. A typical example is calcium and argon. The mass number is the same, which is 40-40, but their atomic number is different, 18 and 20. So they have the same mass number but different atomic number. But of course, they will have different number of protons and neutrons, because number of proton is the same as atomic number. And of course, since their proton number is varying, or the atomic number is varying, their mass number, their neutron number rather, will also vary. For instance, 40 minus 18 will give you 22. So argon is 22, while calcium, the neutron number of calcium is 20. Other examples that exist as this is carbon and nitrogen, potassium and argon, iron and nickel, then argon and calcium that we just did. This is a comparison table between isotopes and isobars. Their definition differ. Isotopes are atoms of the same element with different mass number. Isobars are atoms of different elements with the same mass number. And then the list goes on. Atomic number in isotopes is the same. In isobars is different. Mass number in isotope is different. In isobars is the same, and so on and so forth. Let's look at relative atomic mass. Relative atomic mass. The relative atomic mass of an element is the average mass of one atom of the element when compared to 1/12 of the mass of one carbon-12. We can also define the relative mass of an element as the average mass of its various isotopes as they occur naturally in any given quantity of the element. It is usually calculated for elements that exhibit isotopy. It can be calculated using relative abundance, which is usually in percentage or ratio of the isotopes. So the general formula is usually percentage abundance of A times its mass number plus percentage abundance of B times its mass number. Let's take an example. When the question says chlorine has two isotopes, chlorine 35 with a relative abundance of 75% and chlorine 37 with a relative abundance of 25%. They now ask you to find the relative atomic mass of chlorine. To calculate the relative atomic mass of chlorine, we just say percentage abundance times mass number. The percentage abundance of chlorine 35 is 75%. You just use 75 over 100 multiplied by 35, which is the mass number, plus 25 over 100 times 37. It will give you 35.5, which is the relative atomic mass of chlorine. Then you can do the same for boron. The percentage abundance have been given. And then you can do 20% over 100 times 10 plus 80 over 100 times 11. You get 10.8. This is how to calculate for the relative atomic mass of elements. These are the reference table, the relative atomic mass of few elements that you know. So you can go through them so you can be conversant with them. Let's look at the relative molecular mass. The relative molecular mass of a compound is the sum of the relative atomic masses of all the atoms in one molecule or formula unit of the compound. What does it mean? What it means is that, let's take for example calcium sulfate, CaSO4. All the atoms of CaSO4 are Ca, S, and O. When you calculate when you add all their relative atomic mass together, it gives you the relative molecular mass of the compound. Note that the relative molecular mass of a compound does not have unit. But when we are talking in terms of molar mass, that is where we use gram per mole. But relative molecular mass do not have a unit. Let's take an example of various compounds and their relative molecular mass. Water, and the formula is H2O. That means 2 atoms of hydrogen and 1 atom of oxygen. So we can say the relative atomic mass of hydrogen is 1. But because it has 2 times 1, then 1 times 16, because oxygen here is 1. And the relative atomic mass of oxygen is 16. So 2 times 1 plus 1 times 16. It will give us 18. Let's go further to look at that of ammonia. Ammonia is NH3. That means one atom of nitrogen, that's 1 times 14, because the relative atomic mass of nitrogen is 14, plus 3 atoms of hydrogen, that's 1 times 3, 3 times 1 rather, because hydrogen is 1. So you have a 14 plus 3, and that gives us 17. This is how others are solved as well. Let's look at various questions here. This is a wire question. The atomic number of an element is 17 and its mass number is 35. How many neutrons does he have? Don't forget again, neutrons is calculated by mass number minus atomic number. From that question, 35 minus 17, that gives 18. Another question, which of the following pairs are isotopes? Isotopes usually have the same atomic number but different mass number, so we look out for them. The answer is B. They will have the same atomic number, which is 1212, but the mass number, which is usually at the top, is different. They're having 12 and 14. And then again, note that isotopes are usually same elements, atoms of the same element. Others are atoms of different elements. They are examples of isobars. But atoms of the same element with different mass number are isotopes. You are now given Ar and Ca. Both have the same mass number but different atomic number. Is an example of isobars. Then the next one is, the question says chlorine has a relative atomic mass of 35.5. The questioner says this is because. The answer is B. Why? It is the average of its isotopic masses weighted by their abundance. I have explained it the other time that the relative atomic mass of an element is the average mass of its various isotopes as they occur naturally in any given quantity of the element. The next question says we should calculate for the relative molecular mass of H2SO4. H2SO4, 2 atoms of hydrogen, 1 atom of sulfur, 4 atoms of oxygen. How do we calculate that? Hydrogen is, we are given there, so we have 1 multiplied by 2, because hydrogen is 2 atoms here. That's 1 times 2, plus sulfur is 1, so 1 times 32, then plus 16 times 4, or 4 times 16, because oxygen atom there is 16. Everything will give us 98. These are IGCSE question and JAM questions. Let me pick 1 or 2 there. You have to calculate the relative molecular mass of calcium hydroxide, for instance. Don't forget that everything in that box, in that bracket, there were 2. So you can, if you want to solve this kind of question, you can write by saying CaO2H2 for easy calculation. Why? Because the bracket affects both oxygen and hydrogen. So CaO2H2, Ca is 1 atom, that's 1 times 40, plus O2, that's 2 times 16 plus 2 times 1. Everything will give you 74. So this is how to calculate questions. Again, if you have other theory question, define atomic number, mass number. What are isotopes? You give 2 examples. Distinguish between isotopes and isobar. Give 1 example of each of them and how they differ. And other questions that we give here. These are the model answer for this question. Take your time to go through them as well. A quick revision. The particular nature of matter. Matter is made up of atoms, molecules, and ions in constant motion. with spaces between them. Your atomic number is the number of protons, which is also equal to number of electrons in a neutral atom. Your neutron number is mass number minus atomic number. Neutron does not have mass or charge. Isobars are atoms of different elements that have different atomic number but the same mass number. Relative molecular mass is the combination of all the relative atomic mass of constituent elements in a compound. Brownian motion is one of the phenomena supporting kinetic theory of atom. Mass number is the total nucleus, that's mass of proton and neutrons in the nucleus of an atom. Isotopes are atoms of the same, that has the same atomic number, atoms of the same element with the same atomic number but different mass number due to difference in neutron. And of course, usually isotopes have the same chemical properties but different physical properties. The relative atomic mass, like we define, is a weighted average mass relative to 1/12 mass of carbon-12. These are quick revision that you need to do. If you have gone through this video, you have done an excellent job, and I believe you have mastered the particulate nature of matter. Continue to learn chemistry. I am your favorite tutor, Odisonya Olalekan Adiola. See you in the next video.